got a question where an arrow is launched on Earth at an angle of theta, and then it's relaunched on the moon at the same angle with the same launch velocity. And we know that the moon is 1/6 that of the Earth in terms of its gravitational field strength. And the question's asking, how much higher will it go on the moon than it does on Earth? So we're going to do method 1 here. And in method 1, we're just going to make up some numbers. So when in doubt, you can always make up some numbers and just grind it out, calculate it, and see what happens. So let's do it like we always do any projectile. So we have our horizontal or our x direction and our y or our vertical direction. And I'm just going to make a list of variables like I always do. So vx time dx in the x column, and in the y column I've got v initial in the y, v final in the y, acceleration in the y, displacement in the y, and time. Now when we're trying to find maximum height, height is a vertical quantity, so we're looking for dy. Well, let's take the Earth as our example, and on Earth my acceleration is -9.8. So all we got to do is make up some numbers. So let's make my initial launch speed here, let's make that 20 meters per second. And let's make my initial angle 30. Now as long as I use 20 and 30 on the moon, no problem. I can compare how the height on Earth is compared to that on the moon. So let's have a look. If I use 20 meters per second for my launch speed at an angle of 30, when I go 20 sine 30, I get an initial value in the y direction of 10 meters per second. If I go 20 cosine 30, I get the x velocity, which is 17.3. Now I don't know what dx is, and I don't know the time of flight. So I'm going to put question marks beside all the unknowns. We do know at its maximum height, your final velocity vertically is 0. So if I'm trying to find dy, let's just stay in the y column and solve for dy using an equation that doesn't have time in it. And that equation looks like this. V final squared is V initial squared plus 2AD. Now we know V final, 0. We've made up a number for V initial. Remember my speed was 20 and 20 sine 30 gave us 10. So my initial velocity in the y is 10. Got to square that. 2 times -9.8. And I'm trying to figure out what dy is. I'm going to solve this for d. So rearranging the equation a little bit, I get, if I bring all of this 2 times -9.8 times d over to the left, 2 times -9.8 is -19.6 d. Bring that all over to the left and I get 19.6 d equals 100. So d is 100 divided by 19.6, which gives me 5.1. I'm going to give it 3 sig figs. So that's the Earth height. Now if I repeat on the moon, same equation, V final squared is V initial squared plus 2AD. So this is the moon now. The only thing we've got to change is my acceleration due to gravity. So A is just going to be -9.8 divided by 6, because it's 1/6 that of Earth. So when I work that out, 9.8 divided by 6, I get the acceleration due to gravity on the moon to be 1.633 repeating. And it's still down, it's still negative. It's just weaker than that on the Earth. So again, solve the question. We know V final on the moon at its maximum height is still 0. V initial in the y is still 10. The only difference now is my acceleration is -1.633, and we're trying to find d. If I repeat the question and I end up solving for d, it becomes 30.6 meters. Now the only thing left, and again that's on the moon, the only thing left is to compare the two. If my initial height on Earth was 5.1, 30.6 is 6 times bigger. You can confirm that with yourself. If I just take 30.6 and divide it by 5.1, we get a factor of 6 times. So it goes, the height on the moon is 6 times the height of the Earth.